Hello, welcome to my presentation of Lab 4 for Physics 2211. This goes over spring oscillations and the energy principle. This lab investigation focuses on the oscillating motion of a spring. In this, we use the tracker software to record and analyze an experimental video and then compare it to a GlowScript computational model of the same exact system. This helps us determine if the model follows the energy principle when we compare the two. The result is that the energy of the system remains pretty constant at zero, upholding the hypothesis of the energy principle. There is a slight discrepancy in the end, but this can be accounted for by errors. The fundamental principles of this lab are pretty similar to the earlier ones through Newton's second law, in which net force is change in momentum over change in time. In this case, as you can see over on the left, we decompose it into the spring force and the gravitational force, as those are the only two acting on the system, within the system. We also are including the energy principle, in which change in energy of a system is the work of the surroundings plus the thermal energy applied to it. And in this case, we don't account for any thermal energy change. So the system is defined as a mass, the spring and the earth, and the surrounding is nothing, which would imply that no work can be done on it as there is nothing to apply work. So therefore, we assume that the change in energy of the system will be zero. We'll also be using velocity update, position update, kinetic energy, gravitational potential, and spring potential energy for this lab. So in this, we use this tracker video that I'll play here. You basically select the point mass, and from this, found the mass to be 0.402 that was given. The initial length of the spring was 0.70 without compression. The initial position was negative 0.107 and negative 0.632 meters. And then the initial velocity I assumed as 0 meters per second. It wasn't exactly this, and this causes some of the discrepancies in the results. This is just showing the position of X and Y over time. We use that video to find the initial conditions such as the period, which is derived using these formulas, and we found 1.6079 seconds. We also found the spring force constant and the initial length of the spring. I then put these conditions into the GlowScript code, as you can see here. Probably the biggest mistake was putting the ball's initial velocity as 0, 0, 0. The first thing that we do is calculate the spring length and then the spring energy from this using position and spring force constant. We also find the gravitational potential energy and the spring potential energy to later be added to find the total energy. Like in our past labs, we use a while loop to update the forces on the system and then the velocity and the position. So first we find the gravitational force, the spring force, the net force, and then apply this to the ball's current velocity and position. So in this video, the blue ball is the computational mass, and then the red is the observed mass of the experiment, and then you can see the energies over time. As you can tell, the positions start close and then they diverge, showing some error in the model, and then there's also this discrepancy in the y position, which I think is due to the initial velocity, but I'll discuss that later. So some errors might be the assumption that the surroundings don't have any impact on the system. We do say that no work is done on the system, but in reality, there's always other factors in the system, but we don't know how to compute them yet. And then another thing is in the manual tracking app, I might have misclicked on the mass, causing some variance in the position, which would then have different forces and work and energy calculated. Additionally, I just assumed that the initial velocity was 0 rather than kind of taking an estimate from the first few data points. This was probably inaccurate because when the mass left his hand, it probably wasn't exactly stationary, causing some early variance in the data, which would never be fixed. So the big question of the lab is about the energy principle. So is it upheld? These different forces, as you can see, vary over time, but their sum is this orange line, which stays pretty constant at 0. That's the goal because if the system is isolated from the surroundings, then no work is done on it, and then the energy of the system shouldn't change. So I think that we did uphold this very well. The different types of energy are changing, but overall the system isn't really changing. Some of the errors I talked about probably had an influence in this slight wiggle, which is not the best, but I'm fine with it.